Alright, another draft physics video presentation. Such. Um, so comments and then some discussion perhaps and whatnot. Because the comments aren't very specific usually. Anyway, so the wise monkey says exactly bro. Don't really go for that whole slangy, bro-y crap. Find it a little disrespectful. You know, it's just too casual, too glib. It's just not very useful. Even though it's a positive comment, not very useful. Anyway, but yes, I was substantially correct, as I usually am. Substantially correct. Alright, Scar Runner, for your amusement. I really don't do amusement. So these are like the rules of anime or something, and comparing it to Walter Lewin. Now, Walter Lewin has made a couple of statements that, in videos where I think he's plainly wrong. Radar example, radar interference patterns. Bullshit theory, in my opinion, can be explained as jamming, and the very reason, the whole way they contrive the experiment and putting the audio signal on the energy, use the word energy, probably talk about energy later, is just demonstrates the fact that yes, this experiment doesn't work when you do it the professional way. When you're not doing it for idiots, that is, putting a sound on it so people can see it, like painting it pink, doing something, fiddling with it in some way that is unnecessary to the information you're attempting to glean. It's just doing the experiment the incorrect way, in the sense that you don't ever want to introduce into an experiment any external crap that is unnecessary, because it could screw up the experiment. Anyway, so the very fact that it's done that way is, in my opinion, pretty strong evidence that they do it that way because it just doesn't work right if you do it the professional way. And then he has this idea that there's two voltages in the same location in a circuit where there's an inductor, pretending he doesn't realize that the probe wires are also in the experiment. Again, he's not realizing how the experiment is polluting the environment, not recognizing that these are little controls that you have to always be aware of. In doing experiments, you have to be really careful that you don't have anything in your petri dish and all this kind of stuff, and you have to wear your gloves and wear your mask, and these are certain rules, and he's like disobeying those, pretending those rules don't exist. And he's a professional, he must know they exist, that experiments do require a certain precision to be done right. If you're going to measure voltages in a system where there's radiation radiating, that's just your probe wires might be affected by the radiation. I mean, it's just so obvious. But because it sounds really cool to say there's two voltages in the same place, and look, physics is weird, that's what he wants to say. And so he's making the evidence validate that statement when the evidence doesn't validate that statement. So that's just criminal. It's just malpractice as a scientist. He's committing a malpractice in arguing that there really are two different voltages in the same location. He has to know better. Third, magnets. And this sort of gets to the Tin Man guy comment. The guy's going to comment on magnetic fields. People just don't get it. But so Professor Lewin made the same kind of mistake. There's a superposition principle, which basically the principle is that you can add force, but you can't modify a force with a force. You can change a substance. So if I have a piece of steel and I bring a magnet in proximity, the steel will magnetize. Now if I move the magnet, that magnetism is flexible, and the magnetic field that the steel produces will change, because the steel will modify its magnetism, how it's magnetized, to the position of the magnet. But a permanent magnet, you can't do that. A permanent magnet is saying, I'm magnetic this way, I have a north end and a south end, and you can't change them, can't modify them, that's what they are. You can do it with sledgehammers, you can change them, I'm not saying you can't ever change them. I'm just saying just by moving stuff around, you can't change how the field is produced. These are subtleties, but they're really important subtleties to understanding what's happening in these systems. So again, Professor Lewin had this impression that somehow the fields are changing each other, when no, all you're doing is adding another field, and the field you're adding is a flexible field in the sense that one of the things is a permanent magnet, the other thing is not a permanent magnet, it's an induced magnetism, and the induced magnetism will change if you change the position of the piece of metal. All right. Most of you that just you don't you have to understand the difference between temporarily induced magnetism and permanent magnetism. There's a distinction. Anyway, so yes, Walter Lewin makes errors, and he's unresponsive to pretty much to challenges. Just calls people flat earthers instead of dealing with the point being made, because he has some underlying notions. He has a rigidity in his perception that he won't concede maybe is at least misphrased. There's lots of things you can say about, like, evolution. You can make a statement about its truth, value, the integrity of the evidence, and you can overstate it, you can understate it. It's hard to say it perfectly. It's hard to describe anything perfectly. But that's really the objective, is to do it right. That would be the professional thing to do, is to be as precise and as accurate as possible. I mean, these are just basic, fundamental things. I mean, I really shouldn't have to even, I shouldn't have to explain how that's our objective here, is not to be, not to claim that we've done everything perfectly, but not to be clinging to underdeveloped statements and then reacting to somebody's challenge as if they're saying the whole theory of evolution is wrong, rather than saying, no, you have to understand this doesn't happen in this gradual way. It happens in this way where 10 individuals go west, young man, and end up inbreeding, and all the evolution happened in the small little tribe, and then the little tribe became more capable, and it came back and destroyed the big tribe, overwhelmed it with its success. It doesn't happen exactly the way they draw the crayon picture. The crayon picture gives you an outline, but it has errors in it. It has sloppiness. It bleeds over the edges. And what you need is the precision pencil kind of, the what do you call those thin lead pencils? But anyway, that thing. It has to have these little precise. The idea is to get precise. All right. So, I just don't do the humor thing much. Whatever, 84. Capelic. Koala bear. Magnetic fields change geometry. See, that's just a very dangerous statement. Now, in some sense, it's true that magnetic fields will change geometry if the fields are being created by something that's, say, paramagnetic or ferromagnetic, and you're changing some other, the element that's inducing the magnetism. So if you change the element that's inducing the magnetism, that geometry, you'll change the field geometry. But you will not change the field geometry of a permanent magnet by just moving pieces of metal around. You can add to it. You can create other. It's like the gravity argument. You're not going to change the gravity between the Earth and the Moon, okay, by putting something else in the field. That gravity stays the same. And what you do is create some other force that creates another effect that you have to add or subtract. So you can add and subtract elements. Subtract is the wrong word. You can add things that are anti to the other force, or are opposite to, but you can't take away the original force. You can add negative numbers to the equation, but you can't eliminate a number already in the equation. Magnetic fields change geometry when other magnetic fields appear close. Okay, I'm just saying that's a nice little sentence, but it's only true in specific circumstances. It isn't true as a generality. Ferrite magnets can be easily demagnetized and remagnetized. I already know this. Again, what does that have to do with the specific experiment I'm arguing? Magnetism of these magnets is not exactly sending the magnetic field in exactly the same way all the time when other magnetic fields start to push or stretch the field of a fixed magnet. So again, this talking about a field, again, we're just talking about something like the Earth. It's producing a gravity, and yes, you can't change what it's producing. You can only put more things in the field that could affect something that's nearby by creating more influences. So you can add influences, you can't undo the influences that exist. Alright, the man is serious about his vaping. Yes, I'm a nicotine addict. I vape because I can't afford cigarettes because lunatics have made them, Nazi-esque, fascist, crazy, sappy, insanely stupid people have decided to break all constitutional principle and attack one stupid little vice that's completely benign in the sense that cigarette smokers are a net benefit to society in that they die before they collect all their Social Security and pension money. They make all of you richer, and here you're stupid enough to think that somehow they're a liability. You're just doopy, stupid idiots, hysterically upset because somebody is, addicted to nicotine when you're all a bunch of fucking fat alcoholics. The hypocrisy is ludicrous. But humans are ludicrous. So makes sense. I'm a Serb. That's too bad. Unfortunate for you, I guess. Where Tesla is almost God. Yes, he's almost God to a lot of people, and not for any really good reason. Just because they want some anti-hero. And that's all. They're just looking for any opposite will do. Any it's like rooting for Stalin against Hitler. It sort of makes sense, but doesn't make sense. Tesla was my hero too. And why was he your hero in any kind of heroic sense? I mean, he was kind of a pretentious, worried more about clothes, than practicality. I still respect Tesla's work. Again, fine. I'm just saying that in comparison to what? So this is always in comparison to. People claim Tesla was more than Edison, or more than Einstein, or more than this and more than that. And I'm just saying the overwhelming evidence is that Tesla's contribution was minuscule compared to these other individuals who added so much more to the breadth of our knowledge. But do not like all the myths about him and the many stories that they are fabricated. They are not true. And how do you even know that, right? I mean, all we can go by is the sort of the recorded interviews. There's not much else we can go by because he didn't write a hell of a lot. But be fair, because Tesla knows the same as you said on the beginning of the video. Well, I know, but see, again, this is where you have to use more precise language, right? I mean, because me and Tesla both figured out the sky is blue, doesn't mean we really have anything in common. All DC generators are AC in nature. Well, it's not really their nature, but whatever, you can say that if you like. So it's another statement. It's, it's that, they're AC by consequence of how we design the motors to function, but they don't have to be if you design them differently. He noticed that there is no sense to convert AC generator to DC by commutator, and on the end line by the commutator convert to AC again to be the motor. Well, there is if you want to be able to vary the speed of the motor or you want torque. So you kind of have to do those things if you want to get certain things out of motors. You have to do that. It guided him to find new type of motor. well, again, the principle is that he used phased electricity was his real contribution, was using the phases, the out of phaseness, to eliminate the idea that you have to put brushes on the motor, which was very interesting and nice. But again, those motors don't have high torque. And it is how he came to rotary magnetic field. And again, the field isn't rotary and all that kind of crap. It's just recognizing that you're trying to keep the rabbit ahead of the dogs chasing it. But to be fair and real, I am being fair and real. Again, I've said Tesla, he was a scientist, he studied stuff, he came up with some good observations, but a lot of his observations were absolute crap. His whole understanding of how the physics of the energy functioned was crap. That's why he was trying to make a lightning gun, and he was trying to do it on the surface of Earth where the ground is right there. And he kept thinking if he shoots his lightning high enough that somehow he can get it to go horizontal and never crash into the ground, and that if he even crashed it into the ground, that somehow he could change the ground potential of the entire Earth and pull, voltage out of any spot on Earth. And it was nonsensical rubbish. It was a completely not correct understanding of how this force moves and how it's completely dependent on the existence of atoms to allow something called electricity to be communicated. Without the atoms, you have no frickin' hope. It guided him to find new type of, but be fair and real, dude. Do not overreact always. I'm not overreacting. Clearly, I'm reacting to other people's insane overreaction in terms of their propaganda, and that's all I'm doing. And you have to just do it. And so by doing it, you're saying, oh, I'm beating up on Tesla. No, I'm just trying to quench this stupid hype that somehow Tesla gave us all progress when it's just not even close to the fucking truth. Reacting like this, always like this, is any bad propaganda. I don't know, that's not a great sentence. Reacting like this are the same like the guy you're commenting on. No, I'm afraid it's not the same. So again, you can make that statement, but it's clearly not. I'm doing the fact-checking thing. He's doing the preposterous exaggerating. And somehow, because Tesla's your hero, you're saying, well, just because you're not allowed to sit there and qualify and put this thing back into some sort of perspective, you're seeing that as an attack. It's not an attack. I'm just pointing out the facts. Okay, that Tesla, again, he spent the last 30 years of his life trying to sell a stupid ray gun that he couldn't even make. That wasn't theoretically, he had no grounding for. Like you said in the video from today, if there is more on the left, there is more on the right. As I stated, that all motion is conservative in the sense that it appears that, yes, there's a certain amount of movement in the universe. That movement is always still in the system. So if you move something to the right, you've created a obligation to fill something in the left. You had to move something from the left to the right side. Now there's too much stuff on the right side. It's like pennies. You can move one to the left, and so now there's one more penny on the left than there is on the right. I'm just saying that you can't move something without leaving a space behind. Tesla did a great job and needs all respect as many others. No, I don't think he did a great job. Actually, I think he was kind of a shit as a human being, frankly. Okay, I mean, he was. I mean, there's nothing to admire. He was kind of fucking lazy, I'm afraid. I mean, most of the time. And he pissed away a ton of money on daydreams. Not doing what he was paid to do. Do not pay attention too much about videos like this when you're commenting here. I'm not trying to pay attention to them. You're the people shoving Tesla in my face. Okay, you're people. The people you're defending. They're the one with all this insane hype and this insane notion that Tesla was the inventor of the entire idea of electricity. And it's just such crap. Benjamin Franklin made a bigger contribution, for fuck's sake. And nobody even knows Benjamin Franklin did anything with electricity. Keep up the terrific work. Well, whatever. Yeah, sorry. The idea here is for me to persuade people that some exaggerations and yeah, just some wrong ideas have been immortalized. I mean, made into permanent. They've made permanent marks in the book of truth that just shouldn't have been permanent marks. You know, relativity and bent space and different things, and it's just, you know, the whole idea of quantum mechanics, in the sense of quantum mechanics as mysterious wave functions and you know, the whole wooey parts, entanglement, all this kind of stuff, just exaggeration, antiparticles, all these exaggerations of the truth. And they're just mistakes, they're just errors, and the idea is to convince people how simple these are. Yeah, they made mistakes, and you really shouldn't have written that stuff in stone anywhere, because it really isn't the truth. It's not an accurate description of the reality. And if you really just look at this stuff, you can find very simple explanations that don't require any dark matter and antiparticles and the neutrinos and all this other bullshit that you don't have any role for these things to play anyway. You know, they don't fit in the model anyway. They just seem like a bunch of superfluous bits. So you're not going to lose anything by giving them up, and there's no real hard evidence for any of them. And the truth is, you can understand the physics without them. You know, it's not that you can take all that the mysteriousness out of it. All right, so in case I draw. All right, so Bill Gates guy, you know, does a lot of talking about. So I'll go back to this for that purpose. I think this is him. Yeah. So yeah, he makes a lot of videos trying to talk about this idea of reasoning, but he doesn't. I don't agree with much of what he says. I mean, some of it, yes, but some of it is just so wrong in the sense that he doesn't have much respect. He has, see, this is the thing. The way he says it is the problem more than what he's saying. Because all you really do have is experiments. You know, like this. It's an experiment. There's lots of simple experiments you can do. You can watch something happen, and you have to come up with an explanation for why it happens. And that's all we can do, is take the information we can glean by doing things and saying what happens when we do something. What happens when we let something do something? We watch it, and then we make observations about what it does, and then we attempt to speculate in a rational way, like fitting all of the different experiments. You have to sit there and understand that you have to do this experiment, then you have to do the throwing it experiment, then you have to come up with an explanation that fits all the different experiments in terms of what the phenomenon is or what's happening. So then he's playing with a lot of these vocabularies about what's proof and what's evidence and what's you know, what words we can use in terms of reasoning and logic and all this kind of stuff. And so that part's good, to be aware of what you're after here in the end, which is the accurate description, and that there's rules you have to follow, you know, just the Aristotelian kind of rules of logic, where you can't, I don't know whose they are, but anyway, then obviously you can't have contradictions. You can't have, yes, it matches, it fits for this experiment, and it doesn't fit as an explanation for this experiment. You can't allow this contradiction thing. You can't have those, and then say you've successfully accomplished the task. And the bigger task is really just convincing. It's really just making this persuasive argument that here, you know, I can give you a model that makes much more sense. It's much simpler, and it fits more of the evidence. It explains more experiments and explains the experiments in more detail. So let's just understand the conventional theory gives you nothing. They just say something like bent geometry, bent space. They don't have any accounting for where the energy comes from, how the mechanism actually makes the electrons and the protons in the atom move, how any of that happens. Nothing. Just nothing. So right there you should be saying that's not nearly complete. I mean, it's at best a very incomplete description of gravity. Just almost uselessly undetailed. And then quantum mechanics, they just say virtual photons or the force carrier. Somehow they make attraction and repulsion, and we're not going to worry about it, and we don't know where they come from, so we'll call them virtual because we can't account for the energy again. Where does the energy come from? There's no explanation. So I've explained to you, these are the true facts. Those are the actual facts of their theory. It's got these huge gaps in explanation. Okay, I mean, yes, they have a formula for outcomes, but their description of cause is really lacking. I mean, just almost nothing offered as an explanation of the cause, the mechanism. And that's just the truth. So I call that weak evidence. They've drawn conclusions based on weak evidence because clearly they don't have enough evidence to even draw you a picture, to come up with anything mechanical, physical. In this, they just say it happens. There's a field. Where it comes from, what it's made out of, how it manifests, who cares? And this is sort of the habit. There's a lot of the dissidents do the same thing. They talk about toroids and hyperboloids and all kinds of motion, all kinds of stuff moving places and changing direction. But no explanation of why these things move. Why these are like rivers in empty space. Okay, there's no ground forcing the river to snake, forcing it to turn. There's no mechanism. They're just saying it does it. Just so it's like me saying that a raindrop does this as it's falling down. Wouldn't I have to explain that if my theory was that raindrops really are going up and they're going this way and they're going that way and they're doing all this stuff? Wouldn't you expect me to explain, well, why do you think that, and where does that energy come from for that, and why do they do that? The raindrop somehow says I'm going the other way. So there's no physics in their physics. So that they just won't even concede. They won't even concede that they have just a terribly incomplete theory, right? A model that just doesn't have anything really working on it. It's a kid's model. It's a Tonka toy. Okay, there's a picture of an engine. Okay, there's like an embossed engine. It doesn't even have any parts. It looks like an engine. It has a few lumps like an engine, like little head gaskets and something that looks like a belt, but no real belt, no real pulleys, no real parts at all. So their model is just it's a Tonka toy. It doesn't have any of the real mechanical parts. Just a few. It has a little lever that makes the dump truck move up and down, but otherwise it's missing all the important bits that make a real truck work. This truck just fakes over those, and that's what they have as a model. Their model is that bad. But they're saying, no, it's even better than reality. It's got more working parts because we have a math equation. And the math equation, again, is just a crude simplification. You put a few variables in and you have an outcome out. And you assume that these are the only variables are the ones you put in, that you didn't miss something. You always make those assumptions. And so you basically have to say that somehow flour is sugar. The cookies came out sweet, and well, the only thing we put in was flour and this, and that. We didn't put any sugar in, so the flour must make sugar, or it must turn into sugar. So that's all you get for an explanation. And all people should say all reasonable people should say, okay, that's not finished. That ain't quite right. You can't be arrogant holding a model that childish, that unfinished. This is Play-Doh crap. It just isn't good enough to be so arrogant and pious and obnoxious to challenge. As if you've proven something. Again, this is another burden of proof, and you go into court, and what's your court argument for relativity, or what's your court argument for bent space? you can't put it in a jar. You can't explain where the energy comes from. I mean, you're missing so much evidence, and yet you're so arrogant in saying, I know it's the truth, because everybody else believes it, and that's all you have. It fooled everyone else. Well, so did God. So did Jehovah, and Mohammed, and Buddha, and David, or whoever. Abraham. They fooled a lot of people too. So what? It's crap. All right, so let's play with the word energy. Because conceptually, it's one of those intuitive things, like your impression is, I get energy, bomb blows up. Oh yeah, there's energy. Shuttle taking off, big rocket engine, energy, you sort of get it. Electric bill, energy came into the house, and I sort of get that. I used it. If fan blades turned and engines moved and light bulbs went on and heat was created, and so I know there was energy involved. But what's like the nature of this thing we call energy? And it just gets a little bit complicated. That's probably not the right word. Nuanced in the details. Because what it mostly turns always into is some kind of motion. Atoms moving, electrons moving, proton moving. It's things moving, hands moving. But hands don't move unless the little bits inside the hand move. So it's like following the motion is really the game. And as I've tried to explain, is the energy is in the universe already. It's whether it happened in a big bang or whether it was always there and it's just an oscillating universe. I don't think we have to argue that to be able to concede the point that the energy is not created and it's not destroyed. You could argue that it was created in a big bang and then it is destroyed in the sense that it all dissipates into empty space and goes forever. I don't think it does that, but maybe it does. Regardless, the idea is that the energy is here in the system, and all you're really doing is that energy essentially is a pressure, and so the universe is pressurized. It's heated because there's these little things called force that is acting on stuff, and it's pre-acted. We're in the process of reacting. We're in the process of it already in process. So when we get here, it's already doing stuff, jiggling and vibrating. There's ping pong paddles and there's ping pong balls, and the balls are already in motion, all of them. And you can't kill any of them. You can't destroy any, and you can't add any. So all you can do is change where the balls are, where they're trapped between paddles, what paddles they're trapped between. And I'm saying that's the simple description. Now, you don't have to believe in a particle model to understand that. You could still think of it in terms of some sort of ether analogy. But that's where you have to kind of start, is that the thing we call energy is just the fact that you have something here, a piece of matter that doesn't have energy, and you have this stuff called force, gravity or magnetism, or light, photons, moving the speed of light. So all the stuff moving the speed of light, this force bit stuff. And that stuff transfers its momentum to this matter, the stuff we call matter, and it moves them. So the electrons and the protons all move because something acted on them. The Earth goes around the sun. Now, it doesn't do it because the Earth always existed and the Earth always had velocity. Okay? So there was a history where the Earth had to be ejected. It had to, the energy it has, the velocity it had to be imposed on it by some kind of explosion, some sort of force, some sort of action that had a reaction, where the energy, the ping pong ball went in between the paddles, and the paddles moved, and they pushed other balls, and that created changes in the energy diagram. So you can understand that if I did have 3 ping pong paddles or 4, and I change the number of balls bouncing between these paddles, and that pushes those paddles apart, that's going to affect these paddles, and that's going to affect these paddles. That's energy. So energy is what we see in terms of changes that happen because of changes in essentially the pressure, the number of bits hitting something. And that's what can change in this system through this process of matter absorbing the energy in different ways. Now the atom could absorb it by you hit the electron, and the electron moves faster and faster, and you could sort of say it's because the energy stuck to it. It might be a way to analogize it. You could say that electrons and protons, you're allowed to stick energy to them. So when a little ping pong ball hits, it sticks, and it just keeps moving in that direction it was going. So it keeps continually applying some amount of momentum to something. That's probably a closer analogy to what really happens. I've explained what I think really happens, which is electrons and protons have already captured energy, pressure, and they already have inside of them ping pong balls trapped inside, going back and forth. And really the only thing to be decided is how much time do they spend going this way versus this way. And that's what you can change by putting a new one in and letting an old one out. Because you put the new one in at hitting the surface quicker than this one that you're letting go. So you're just exchanging a ping pong ball going this way for one going that way, and that interaction will always end up with you having a tendency to move in a direction, the direction that you captured versus the direction that you released. And that's how it really works, is that it's an absorption of the force, a capturing of it, but you can't capture without releasing. So that's the rule. And that's a rule built into the already moving and working universe. The electrons were already made, and the protons are already made, and all that stuff is semi-indestructible also, like the energy. It's pretty hard to destroy an electron or to make one, as far as we know, of course. Alright, so I don't want to get too detailed, but I do want to just point out that, so basically the word energy just means, for us, is where we see a differential, where we're seeing the transition. That is, where the balls going this way are being added and the ones going that way are being released. When we see that happening, then we see matter move and we say, energy. And really it's just transition. The thing already had energy in it. It already had potential in the sense there was pressure inside. And it's just making an exchange. And you could say that the absolute energy of the system is sort of the E equals mc squared thing, where Einstein is basically pointing out that inside the atom is already a ton of pressure. And if you can break down the mechanisms that are holding that thing together, you can release a lot of what we call energy. And what you're releasing is the force bits. You're releasing the ping pong balls. So you're taking ping pong paddles that have trapped a whole bunch of balls between them, and you're tilting them or doing whatever you need to do to make all the ping pong balls just fly out now. And that's essentially what you're doing when you nuke some matter. And it seems like it's quite obviously happens in all directions equally, smoke ring kind of idea, mushroom cloud, all kind of a consequence of the geometry of the explosion, in the sense that the matter obviously does trap energy. When it's in an environment where it's static, it sort of means that the atoms have a balance to the relative environment they're in. So even when the nuclear bomb is nuking, it's also moving through space. I mean, it's rotating on the surface of the Earth. It has all of that. It has a bias in its energy distribution, but we don't see that bias because we have the same bias in our energy. So we are all got a velocity. Everything on the Earth has this velocity. It has energy through the universe, relative to the universe, relative to the galaxy, you could say. We're moving very fast in a direction. But we don't notice that energy. because we don't have anything to compare it to. We can't make a relative comparison to something else that's doing something else and realize, oh, we're being very energetic. So most of the energy, we don't see it, obviously, but it's there. So the energy of the compression of the atom when it was born inside of a sun, that energy's in it. The bias of its motion through the universe, that is, it's on the earth, it's rotating, it's doing all these things, that bias, that energy is in it, but we don't see it. So that's in this form of potential energy. It has the potential to be seen, in the sense that it has a potential to turn into what we call kinetic energy, which is energy actively making exchanges, where matter is changing direction, and that we call energy. Energetic. So it's really just not a great word describing a general idea of stuff we see as the physics of force interacting with matter. But matter already contains energy, and it's interacting with force all the time, and so it's always under some pressure. There's always some influences, and there just means that there's an influence where two boxers are hitting my head at the same time. Now, you'll see this energy of them, but you won't see the energy of me, the compression, because it won't have a bias, but it doesn't mean there wasn't energy put into my system through that interaction. Energy that'll cause all kinds of hemorrhages and other things. All right, so that's probably, it's. So anyway, so it is a loose term. So when we talk about energy, I guess the point is that you can't really come up with a specific enough definition that is broad enough. So you can't create a word that's both specific and general, and energy is attempting to do that, which is kind of, you just can't get away with that crap. What do I do with my book? I have a book. I know I brought it with me. Here it is, my book of notes. So what else do I want to get to? So so it's the whole. So when you talk about energy, then it's related to words like momentum, and you could argue that this is all about just transferring momentum, and all you're doing is transferring momentum in the form of the force, which is the stuff moving the speed of light. So gravity, magnetism, photons, light, the electromagnetic spectrum. It's all just little bits of stuff moving the speed of light, and those bits have momentum, and they're basically exchanging momentum. So if an electron is sitting here and a force bit hits it this way, the momentum of that force bit is absorbed, kept inside of the electron, and it releases a force bit going the other way. And so inside of it, there's a net change. It had a bit going this way, it now has a bit going this way, so it's net impulses to move because of that imbalance. So it's I've made this analogy. I guess I'll just keep reinforcing it because I think it's an important analogy to understanding. It's like you have a boat with 10 seats, and all you're doing is changing which way the rower's rowing. And so when force interacts with matter, when force interacts with an electron, the electron has no I want to do anything. It just has rowers. And so if it has 5 rowers going forward and 5 rowers going backwards, it doesn't go anywhere. But if I interact with it and kick one of the guys going backwards out, and I replace him with a guy going forward, well, now it's going to have a bias. 6 rowers going forward, 4 rowers going backwards. Now it's going to go forward. And the universe, basically, that's how momentum is exchanged. So, and as the boat moves, so I'm a boat, and we have to understand that the boats are all related to each other in the sense that the boats are constantly making these interactions, these exchanges. And so every time something goes in, something goes out in the opposite direction, the equal but opposite reaction. So when I make the exchange and I absorb a rower going forward, the boat ahead of me isn't going to get hit by that rower now. I stop that from happening. And the guy behind me is going to get hit by a rower, because now I sent one back in his direction. So now his boat's going to get hit by a rower going the backwards way, and he's going to tend to go slower. And the guy ahead's going to go slower because I stopped one of the little bits that are going the speed of light from hitting him in the butt and moving him forward. So he's not going to go at the speed he would have been going if I wasn't in the way. Just facts. And so that's how this momentum thing is exchanged between one matter bit and another matter bit, is because there's the rowers and swimmers, you could call them, the moving bits, the mover bits, the rowers. Let's just call them rowers and swimmers. They're the same thing. They're swimmers when they're going between boats, and then they're rowers when they're in the boat. Okay, so whatever we call them, the guys who, the people in the boat, I don't know, what do we call the little force bits? But that's what the force bits are doing. And so there's the exchange of momentum. And so when one object moves, one boat moves, it affects the other boats, because they're constantly exchanging rowers, and they're exchanging rowers, and you're exchanging rowers with every other boat in the universe, technically. Well, technically you're not doing it with every other boat. You're doing it, you're radiating. And yes, some of your photons will reflect off you and go to the moon. Tiny number of them, maybe. But some of them will. Maybe. If you waited 10,000 years, certainly some would. If you only to wait 10 seconds, well, maybe none of your photons will get to the moon. And if obviously the moon's on the other side of the Earth, there's very little chance any of them will get there. So I'm just saying that you're interacting with the universe broadly, but not every single bit of the universe at every single moment. It's just that over time, you spread it all over the place eventually. Over time. It's like a spray can of paint, right? If you just press the button for a second, some of the dots go to certain places. Now, if you hold the thing down, well, then you cover the whole thing eventually. You go everywhere eventually. Eventually. With enough time, you'll shoot a photon at everything, everywhere. Just about. See, I made a statement. You'll shoot a photon everywhere eventually. And I'm saying, well, maybe that's not exactly true. Because you are on the wrong side of the Earth, and maybe this never rotates in that proper position, so you never can hit one spot in the universe because you never have a clear shot. So I don't want to say, see, again, precise language is sort of important. And it's difficult, and that's part of this challenge. But my challenge is just to say to you, look, I can explain everything that happens in the universe. All the experiments can be explained by just understanding that there's this stuff called force that has momentum, ping pong balls, and then there's stuff called matter that absorbs this force, that is impacted by the force when the force hits it in very specific ways, and that you can explain all the phenomenon, and that magnetism especially becomes quite obvious if you just give these force two functions. You just make red balls and blue balls, and you have a rule that says the blue balls do this interaction thing that goes forward to back. That is, when my guy goes in, a guy going the opposite direction comes out. And then you have another rule for the red ball, which means when my guy goes in, a ball to the left or to the right or up or down comes out. A ball comes out of one of the other dimensions. It doesn't go reverse. It comes out one of the other two dimensions. And that's it. The simple rule. So you can explain magnetism. You can explain why there's high pressure, low pressure in these systems. And you can explain where the energy comes from. So when things happen, when the Earth moves towards the sun because of gravity, well, it's because there's real swimmers in the ocean around both of us, and we're going to exchange swimmers in a very different way when we get closer and closer to each other. And if we're magnetic, we're going to do it really differently, because I'm going to segregate, the ones jumping out of my boat from ones that are reflective or ones that are absorptive, ones that leave perpendicular versus ones that make the opposite exchanges. And by changing those rules, we can affect each other rather dramatically by being in proximity to each other. By getting closer or further away will really change which way we go. And so all of the phenomenon we see can be explained with this simple model. So you don't need any antiparticles, and you don't need any entanglement nonsense of somehow special particles are somehow connected to each other and all this crap. All you have is stuff moving the speed of light. It communicates momentum to the stuff that doesn't have any innate will. The boat doesn't want to go anywhere. It doesn't have any innate momentum. It just depends on what rowers are in it. And that's it. And the rowers are the swimmers. So the force is either in the matter, in its motion, the motion of the electron, the energy is either there, or it's in the ocean. But it's never not somewhere. So the little bits moving the speed of light are either in a boat, rowing, or they're free space moving. And so when it's free space, it's a photon traveling through space. When it's in an atom, it's a swimmer between two boats that just keeps jumping in one boat. This guy jumps out, goes into the other boat. This guy jumps out, goes into the other, and they just keep doing that back and forth. They just keep making the same exchange over and over and over again. And that's how energy gets trapped in atoms. All right. So, yeah, that's sort of an overview. It's probably enough to get into. But again, it's just this. The bottom line is I'm telling you, this works. I've played with it for 7 years now, or 10 years, whatever the hell this has been. Tested it, beat the hell out of it. And I'm just saying, if you go to the trouble to listen to, say, the subject videos on the playlist on my channel, the one on magnetism especially, you'll see it gives you a really complete explanation of why there's repulsion, why there's attraction, why the same force is creating, the same basic force is creating these two opposite reactions. And it's just it's so simple in terms of understanding how it's mechanically working. Why does stuff move? This theory explains to you why stuff moves. Nothing turns its direction. Nothing goes in a circle. Nothing orbits. Nothing does any of this stuff unless there's a force, momentum, swimmers, pushing it. Everything is, all the matter bits have no will. They have no, they do what the force tells them. They do what the swimmer bias imposes. And by understanding that's how the universe is working, it all falls into place, it all fits together, it explains what's happening here in this universe. And with such a simple diagram. I mean, it's just a black and white, a black and red checkerboard and black and red checkers. It's that simple. And you really should be reasonable and say, yeah, okay, I can see where you're going, and it's hard to challenge. Yes, you have to just admit, I can't come up with a reason why that can't be the truth, because yes, it does fit what the evidence indicates. All right. So, but so far, you're just all a bunch of cement-headed retards, clearly. Not all, but tiny, except for the tiny percentage, the useless percentage, in a sense. Because what I have to get is these people who are professionals at this have done some physics, spent some time looking at experiments, spent some time looking at the formulas and what's actually in them. Those people really should be capable of understanding, oh, this is so much better than Copenhagen and all this wavy crap and all the rest of this nonsense. So much better, so much cleaner, so much more efficient at explaining. This model works where their model doesn't. Their model is all just a bunch of fake embossing. This model has a real engine. It has a real working steering wheel. It has a real gear shift. It has real parts, not virtual photons and bent geometry. Shit. So anyway, till the next time. and such. I think it's enough. I feel the enoughness. Yeah, I feel it.